Now let's consider a simple electric circuit with the resistance of 3 ohms and an inductance of 2H. If the battery gives a constant voltage of 24 volt and the switch is closed when t equal to 0, the current IT after t second is given by a differential equation, di per dt plus 3 over 2I equals to 12, where the initial value is when t 0, I is equal to 0. So the first question is to obtain IT, and then second question, determine the difference. Okay, the meaning of difference is subtract, okay, minus, okay, in the amount of current flowing through the circuit from the 4th to 8th second. That means we have to substitute t equals to 8 and subtract when we substitute t equals to 4. So we are going to obtain the difference and give your answer to 3 decimal places. If the current is allowed to flow through the circuit for a very long period of time, this means infinity. Estimate IT. Okay, so you are given a differential equation model, okay, which is di per dt plus with 3 over 2I is equals to 12. So this is non-separable. So we have to solve it using integrating factor. Okay, so we know we have to find the integrating factor first. The integrating factor formula is exponent to the power of integration of p, okay, function is in terms of t with respect to t. Okay, so from the model we know that our p is 3 over 2. So we have e to the power of integration of 3 over 2 with respect to t. So the answer we are going to obtain is e to the power of 3 over 2t. So that is our integrating factor. And then we have to multiply the integrating factor to both sides. So our model just now is di per dt plus with 3 over 2I is equals to 12. So we have to multiply both sides with the integrating factor. Okay, so we have to multiply this side and this side with integrating factor, and our integrating factor is exponent to the power of 3 over 2t, and this side also we are going to multiply with e to the power of 3 over 2t. Okay, and then for the left hand side, what happened is this part will be eliminated completely, and then we are left with, okay, first we are going to write this d per dt outside. So we put d over dt here, and then the rest I and our integrating factor. Okay, so we still have I e to the power of 3 over 2t, and then equals to 12 e to the power of 3 over 2t. And then I'm going to bring dt to the right hand side. So we have d I e to the power of 3 over 2t is equals to 12 e to the power of 3 over 2t dt. And then we are going to integrate both sides. Integration sign and d will cancel each other. So for the left hand side we are left with I e to the power of 3 over 2t is equals to, okay, so 12 is just constant. How to integrate exponent? Okay, we just copy back the question, and then we are going to differentiate the power and we divide. So we are going to divide with 3 over 2. Okay, so lastly we are going to obtain I e to the power of 3 over 2t is equals to 8 e to the power of 3 over 2t, which you can calculate. 12 divided by 3 over 2, we are going to obtain 8. Okay, but we want I, so I will become subject, but don't forget to plus with c after you integrate. Okay, so I will become subject, so that means we are going to divide this to the right hand side. So after dividing, the answer will be 8 only, okay, because e to the power of 3 over 2t is divided by e to the power of 3 over 2t, and then plus with c divided by e to the power of 3 over 2t. That is what happened when we bring e to the power of 3 over 2t to the right hand side. So this is our answer. Okay, but we can find the value of c. Okay, we can find the value of c because in the question we are given when t is 0, I is equal to 0. So we can find our c by substituting. So I is equals to x plus c over e to the power of 3 over 2t. Okay, and we are given our initial value like this. Okay, so now I'm going to substitute. So our I is 0. Okay, when t is 0, so we get c over e to the power of 0 because now t is equal to 0 according to this condition. Alright, so we can obtain the value of c. So 0 is x plus c because e to the power of 0 is 1. So c is equals to negative x. And then let's resubstitute. So it will be equals to x minus x over e to the power of 3 over 2t. That is our I. And now let's go to question B. We want to obtain the difference when the current flowing through the circuit from 4 to 8 seconds. So that is what we are going to do. So we are going to find Ix first. Okay, Ix first. So Ix equals to x minus x divided by e to the power of 3 over 2 times with x. Okay, and then we have to calculate the value, and then we have to calculate I4. So I4 is x minus x over exponent to the power of 3 over 2 times with 4. Okay, so we have to calculate the answer. For this one, we are going to obtain 0.79999, and for this one for this one it is 7.999. Okay, sorry, and this one is 7.9802. Okay, then we have to subtract Ix minus with I4. Okay, so the answer will be 0.020. So we obtain 3 decimal places. And now let's look at question C. If the current is allowed to flow through the circuit for a very long period of time, that means we are going to substitute t with infinity. Estimate IT. Okay, so we know our IT is equals to x minus x over e to the power of 3 over 2t. And then if we take our t to approach infinity, okay, so the answer will become x minus x over e to the power of infinity. Okay, we substitute our t with infinity. Okay, so when x divided by infinity, you are going to obtain 0. Okay, so the answer when t is a very long time, I will be x. Okay, that is the answer.